So we talked about similar polygons a little bit when I was showing you similar triangles and how we write similarity statements. A couple of chapters ago, I did it as an extra lesson, so some of this might be review. But essentially, how can we relate polygons together? And what we're going to learn, our learning targets, are how to use similarity statements, find corresponding lengths in similar polygons, find perimeters and areas of similar polygons, and decide whether polygons are similar. So a few things that we're going to cover, starting with, no new vocabulary here, but starting with, in the diagram below, ABC is similar to DEF. You can write triangle ABC is similar to triangle DEF as that symbol right there. Okay, this means is similar to. So not congruent, but similar. Now, when you have something that's similar, you'll notice all the angles are exactly the same. But what's different is you have your A multiplied by the same thing that your C gets multiplied by, that your B gets multiplied by. So basically you have a factor of K here that you're multiplying by A, C, and B to get a bigger triangle. So the angles are all equal, congruent, equal in measurement, but the sides are a ratio or a figure of K. Ratio just means a comparison between two numbers. In this case, we're comparing the two sides. So if you take a look at this here, if two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. So if I wanted to set this up, you can notice that this is a long side and this is a long side. And this is a shorter side and this is a shorter side. So if I wanted to set this up as a ratio to solve for x, I can do that because I can say 3 over 2 is equal to 7 over x. And I can set up a proportion and solve it. So if I was solving this one in particular, this would be 14 divided by 3, so x is equal to 14/3. So by what factor did this increase? Well, you could actually do that too. I'm not going to get into that just in this problem though. So this right here, if you take a look at it, you're going to compare sides that are the same. So you have this right here that you need to solve for. So it's between the 1 and the 3 marks. So between the 1 and the 3 marks is right here. So you actually have x over 25. And then you could use any other two sides you want. I'm going to use this one just because it's right here. It's between the 1 and the 2. So between the 1 and the 2, and I'm talking about these marks in the corner here, it is 20 over 8, or actually, sorry, 8 over 20. And you could cross multiply and divide. So that would give you 200, so x is equal to 10. Okay, so we did a lot of proportions when we were doing that extra lesson. This is kind of pretty much the same thing. We're just using polygons, not just triangles now. So the perimeters of polygons, if they're similar polygons, then their perimeters are exactly similar as well. So if I was to multiply this by 2, and I would get the side 2 times bigger, right? Well, if I multiply the perimeter by 2, then this perimeter is 2 times bigger. So the perimeters are equal to the ratios of the corresponding side lengths. So whatever factor you did here is going to be the same with perimeter. And this K is just a factor. Area is a little different. And I talked about this when we did the triangles. Area is a little bit different because this is square units. This is the inside of the figure in square units. So when you have square units, you have to use the square of the ratio. So if the ratio, for example, was 2/3, I would need to square the ratio, which means I would actually use 4 over 6 sorry, 4 over 9. I brain farted that big time, didn't I? 4 over 9 to actually figure out that. So the K factor here, if you're looking at just area, is going to be 4 over 9, not 2/3. If I was doing perimeter, it would be the 2/3. But if I do area, I have to square it, which means I have to square and square. Okay? All right, let's try some, because that's when we actually really get into what we learn. So in this diagram, DEF is similar to MNP. Find the value of X. Well, if I look at my similarity statement, EF is similar to NP. It tells me that in my statement. So even though I don't have all my angles marked, I can see in my statement that that's actually true. So I can just do X over 30. I'm just doing the little one compared to the big one. And then I can just pick any other side. So I'm going to pick ED, no particular reason. ED is similar to MN. So that's the side I'm going to use for that. So this is 15 over 18. And I would just cross multiply and divide and get X equals 25. So just so that you know that, you can write this also as X over 15 equals 30 over 18, and you'll still get the same result. Okay, so either way you would have wanted to write that, you can. You can do big to small, or you can do small triangle, the whole small triangle, to the whole big triangle. And we did a lot with this when I did that extra lesson a little while back. So take a look at the next example. In the diagram, triangle TPR is similar to XPZ. So find the length of the altitude. So remember the altitude is this right here. That is your length. So you're looking at 6 over 8, mostly because I'm using these right here. 6 over 8 is equal to X over 20. And I'm getting that from right here. I'm going to call that X because that's what I want to find. And this is your 20. So 6 over 8 is equal to X over 20. Or you could have done 6 over X is equal to 8 over 20. And that would give you the same result. Either way, X equals 15. If you're not sure how I'm getting that, I'm just cross multiplying and dividing. So multiply the two numbers that you can, divide by the third. Multiply, divide, multiply, divide, multiply, divide, multiply, divide. And you can see you're dividing by the same thing. Because when you cross multiply this, you would end up with 8x equals 6 times 20. You're cross multiplying. Okay, that's just calculator work at that point. Once you set up your problem, that's the geometry. Then it becomes calculator work. So let's take a look at the next problem. So if you take a look at this, you're seeing almost looks like a trapezoid, but I don't think it is. Again, you're going to do some comparisons here. You're wanting to find the value of X. You are given a congruency statement. So first of all, figure out where your X is. BC. So that relates to RS. So you can set this up as X over 4. Right? X over 4. And now you're taking a look at this and you're like, okay, well, I got that. So which other sides do I want to use? I could pick any of them. So if you want to pick this one, you can. And then that is 12 over 6. So 12 over 6. Notice I kept the same direction. I went to the right, to the right, right, to the right, to the right. X over 4 is equal to 12 over 6. And there you go. So then you solve that. Again, calculator work at that point. If you want to find Km, same proposition. You have X over 48, because this is Km right here. So X over 48. And then you have 35 over 40. Calculate it, and you get 42. A town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25. The new pool will be similar in shape to the Olympic pool, but will have a length of 40 meters. Find the perimeters of an Olympic pool and the new pool. So this pool right here is 25 by 50. So 25 over 50 is equal to x over 40. So if I want to find the perimeter of the Olympic pool and the new pool, I can actually just find the length of the other pool because I know it's going to be 40 meters. I have a length of 40 meters. I can find the width of it, and I get x equals 20. Now, the perimeter is when you add them all up, right? So 50 plus 50 plus 25 plus 25 is 150. And the perimeter of the other pool would be 40 plus 40 plus 20 plus 20. So that's 120. And this is the perimeter of the Olympic pool and the new pool. And that's all you gotta do for that. All right, so this one, the two gazebos are shown, they're pentagons, five-sided figure. I wanna find the perimeter of gazebo A. So this is x over 10 and 18 over 15. So x equals 12. Okay? So this x here equals 12. So the two gazebos shown are similar pentagons. Find the perimeter of this. Well, these relate because this one is 2/3 bigger. So this is like 2 to 3 ratio, right? 2 to 3. And if the perimeter of this and the perimeter of this, if I add up all these numbers, I would get 15 plus 18 plus 9 plus 12 plus another 15. So that's 30, and that's another 20, that's 59. Hopefully you got that. I just added all these up, so the perimeter is 59. Well, this one is 2/3 of that. So 59 times 2/3. So 59 times 2 divided by 3. I don't think that goes in very evenly. I can actually get my calculator. I know, but I don't think that actually goes in evenly. I'll find my calculator first. Got a mess here. 59 times 2. No, it's 39 1/3. And that is the perimeter of this figure. This one side is equal to 12, but the perimeter is actually 2/3 less. Okay, area. Area is a little bit fun. So in the diagram, find the area. If you have, whoops, dropping stuff here. That's better. Okay, so in the diagram, if you have the area of ABC is 36, so this is 36 centimeters squared, and I want to find this. Remember, I need to take the ratio and square it. Well, the ratio here is half. This goes down by half, so 10 divided by 2 is 5, but remember these have to be in fraction form if it's division, so it's actually half. So if this is half, you would think to yourself, well, I could just divide this by 2, right? No, don't do that. You'll have a bad day. So what you actually want to do is take 1/2 and square it, and you get 1/4, and that's the ratio you're going to use to compare the two. So 1/4 is equal to x over 36. So you get 4x equals 36 or x equals 9. And so this is 9 centimeters squared. The reason that I have to square the ratio It's because this is in square units. Okay, let's try it again. Find the area. So the area of this triangle, or sorry, not triangle, this rectangle right here is 84 meters squared. So if I want to find the area of the other one, I just need to figure out what the ratio is. So this is 7 over 21, which is equal to 1/3. And if I square it, I get 1/9. That's the ratio I want to use. So 1 over 9 is equal to x over 84. So 9x equals 84. So that equals 7. Should actually equal more than that because it's bigger. So I'm looking to see what I messed up here. 1/3, 1/9. Oh, I think it's telling me it's 7 times bigger. So then I need to multiply that by the 84. I don't want to do that. So I'm going to leave this as 7 squared over 21 squared. And I'm going to do x over 84. And then x is going to equal 756 meters squared. So you can just leave this ratio alone. You don't have to reduce it. I reduced it here. I got an answer, but then I have to unreduce it. I don't want to have to do that. So I'm just going to leave it as it is and do it like that instead. Okay. So decide whether these are similar. If you're wanting to figure out if something is similar to another figure, what you need to do is compare them. So if you're deciding it's similar, take a look at little places that you can actually compare them. So like 6 over 4, and then you see the one that's right next to it is directly above this little mark right here. This mark right here, so directly above. So then it's equal to 9 over 6. If these are equal, you can cross multiply them and get the same answer. If that's true, then these are equal. And then you can write a similarity statement. So A, B, C, D, E is similar to, and I started with that right there, and then I went to the side and then up, so K, L, Q, R, P. And that's your similarity statement. So for two figures to be similar, the corresponding angles, the angles that they relate to, have to be congruent. And the corresponding lengths must be proportional. Okay, that concludes that lesson. Sorry, it kind of took a little bit longer than I expected, but hopefully you got some good information. If you have any questions, please let me know.